Okay, dear friends, I'm back with another machine on the Hex box, which is DriftingBlues line. I will add the link into the description section below so that you can download it. Before we start today's journey, if you don't mind, please subscribe to my channel and leave a like below. You're greatly appreciated. So enough said, let's just get started. To save time, I've already imported the machine into the virtual box. So now we can, of course, the introduction of this machine. And this is the address of the machine. And in this episode, I'd like to showcase how to exploit a buffer overflow vulnerability. So now we can get started. As you can see, I have already done the map scanning with the UU option like scene scan, the version scan, the default script scan, and also the comprehensive scan. From the map scanning results, as you can see over here, the 3 open ports. The first one, I think this is the most important one, which is running HTTP service. And I think the other 2 ports are not very useful. So what we are going to do next is to do emulation for the web application. We can launch our browser of Firefox and put IP address of the target. Press enter. And the DriftingBlues tag is sold. And of course, the first thing I'd like to check is source code of this page. And then we can scroll down to see whether we can find some interesting information. Yeah, this script was generated by PHP microblog and also the actual version information. Yeah, which is so useful information, right? So we can make a copy and use the search sprite to see whether there is any vulnerability for this application. Yeah, there are several exploits available. And also, from the source code of this page, we know the version, the exact version. So I think this one is what we are looking for. And apparently this is the Python script. We can make a copy of this relative path and search sprite with option M and paste in here. So now we got the copy of this exploit. So maybe we can open up this Python script to see how we can use this. I think this is written in Python 2, right? And we just need to provide the URL. So maybe we can run it to see whether it's working. Let's press enter. Yeah, maybe we do not need index PHP. Let's press enter. Yeah, it looks like it's working. Now we can run command ID. Of course, as I stated in the other video, I don't like web shell very much. So it will be better for us to spawn the normal shell. And we can check netcat. Yeah, netcat is there. Now we can open up another tab and set up the listener first. And now go back here. And now we can run netcat to connect to our Kali Linux bin bash. And the IP address of the target should be this one, right? Let's press enter. I think it's working because no error. Yeah, we got the collection. Now we can, yeah, of course, we need to normalize this shell. And we can check the version of Python. Yeah, Python 2 is there. And import pty module, pty spawn, bin bash. Yeah, it's much nicer. And now we need to do some local immersion because we want to make a lateral movement. First, we can navigate to the home directory. Yeah, there is one user, CD Clapton, permission denied. So I think we can go to the www root directory. You know, often we can find the credentials for the database collection. HTML. All right, and now we can go to the admin. Maybe include always configuration files are located in this directory. And now we can cut out the settings. Inc. PHP. Yeah, but no password. So maybe another one. Cat base in PHP. So I think now, yeah, we got the username and the password for the database collection. Of course, then we can log into the database with this credentials information. However, because the username is the same as the system username, right? So I think we can try or attempt to use the same password for the user Clapton. We can switch Clapton and we can copy the password of this user and we can paste in here. Yeah, it works. Now we can get the user flag without any issue. And also there is another text file. Note, yeah, buffer overflow is the way. If your new 32-bit buffer overflow, then click this. So I think till now it's not very communicated with the machine. Now, yeah, at this point it's pretty clear that we need to exploit the buffer overflow vulnerability. And the way to do it, first, I think we need to download this input because this input has the SUID bit. So I think we can spawn the new listener with the different port number, right? And we can write into the input, the same file name. And now we can go back to here. So now we can use the netcat. We can cat input and tunnel to the netcat and the IP address of the Kali Linux and the port number. Let's press enter. We got back the content or data from this file. So we can close down this collection. And now of course we can change mode or make it executable for analysis. And before we can use the debugging tool like GDB to analyze this binary, we need to disable the ASLR capability of the, as you can see, the ASLR is the technique that is used to increase the difficulty of performing a buffer overflow attack that requires the attacker to know the location of an executable in memory. First, we need to disable that. So how to disable? We can echo. We echo 0. And now we can cut the result is 0. It means that we have already disabled the ASLR feature of the Kali Linux. You know, in modern operating system, always this feature is enabled by default. And now we can launch the GDB. And before we do that, we need to generate the pattern. Generate the strings with a specific pattern. And this string is used to calculate offset. As you know, all variable, like a local variable, is stored in the stack. Stack structure. And the offset is used to the offset combined with the EBP, and to get the address of the variable. So I think to get the value of the offset is very, very important. And there's some Ruby script can help us to do that. And because this need a bit of complicated, I must admit. So generate this, the string with the length is 1000, and we can just copy this command to generate this string with pattern, specific pattern. So now we can launch. Maybe we can sudo, and we can run this. Run and input. This would be input. We got the address of where segmentation fault happens. So now we can use this address to calculate the offset. The command is this one. I just make a copy. And then we can open up another tab, maybe. And the address is this one. We just copy this address. All right. The exact match at offset 171. And then how to do it? We need to construct a string based on the offset value. I just make a copy of this one and run inside the GDB debugger 2. And we can run and paste in here. Started from the beginning. This is the address, the segmentation fault. Then we can use, and we use this one. No, we can get the ESP register value, and the command would be this one. This is the value of the ECP register, and we can make a copy. And then we can combine or generate the payload. And because this address is the little endian, so we need to reverse the address like that. Okay? And this address. And I also put this payload if if it's allowed into the description below. Okay, so we just make a copy of this one to see whether this is working. Yeah, started from the beginning. Yeah, it has some error. Print. Sorry, I need to Python 2. And then I think I need to change the address of the segmentation fault. F0 and D3. I think it's correct. Now press enter. Yeah, as you can see, we have already successfully run the bin bash and got the root privilege. So yeah, so far we have already exploited the buffer overflow vulnerability locally on our Kali Linux machine. And we need to repeat this process on the target. We can exit. And now go back to this one, the target. So I think however, we don't have a permission to disable the ASLR feature. And however, of course we need to check whether GDB is there. Yeah, it's there. So now we can run GDB input. All right, and then we can run the same command. For example, the first one. Yeah, I think we can run this one to get the. Yeah, I think the offset value should be the same, and we can run. Maybe we do not need Python 2, so I need to exit. Which Python? Yeah, Python 2 is there, so we can run. We make a copy. Yeah, this one. Yeah, the Python 2. So we can run. Oh, I need to launch the GDB input, and then let's paste. Oh, sorry, I still forgot to put ROM and paste in here. Yeah, we got the same address with the segmentation fault. Next, we can view this register. So this is a bit different, right? So we can make a copy of this one and then put it in here. So we need to, should be B00 0 and E6 and then E6 C9 and BF. So we can run to see whether this can work. I need to make sure my ESP register value is correct. However, it's not correct. No. So this one is not correct. Zero, zero. Yeah, I think. So I think the problem is caused by the ASLR. So we need to run it in a loop to defeat this randomization. And how to do it? And we just make a copy of this here. And then we can replace all right, then we can replace here, all right, and we can make a copy and paste in here. To see whether we can exploit this buffer overflow vulnerability. All right, as you can see, we have already successfully exploited this vulnerability of a buffer overflow. Now we can go to the root directory and we can get a root flag without any problem. Okay, so that's pretty much it. I hope to see you in the next one. Bye.